Using the fundamental theorem of algebra, we want to look at the maximum number of solutions. So we want to look for the highest degree. This is 1 if it doesn't have a number. So because my largest number is 7, then 7 is the maximum number of solutions. If we look at the next problem, this one is actually in standard form. We look at our exponents, and the highest exponent is 6, so we have a max number of 6 solutions. Okay, so for our first problem, we have the sum of cubes. So we have a plus sign in between, so we know we need to use the sum. When you have the sum of cubes, you want to do the cubed root of x cubed, and then the cubed root of the second term, which is 125. We don't worry about the plus sign because it's taken care of in our formula. So a is going to be x, and b is 5. Because we have a squared and b squared in the equation, we're going to square them also. So this will be x squared, and this is 5 squared, which gives us 25. So we're going to be using this equation, but instead of a, we're going to use what we have for a, which is x, instead of b. So we're going to put plus, and instead of b, we're going to put 5. And then we're going to now use a squared, which is x squared, and then minus a times b. So we're going to be multiplying these two. That gives us 5x. That's going to be my a times b. And then we're going to add b squared, and we already have it as b squared. Let's take a look at the next one. We're going to be using, again, the difference of, well, now we're going to be using the difference of squares. We know it's a difference because there's a minus sign. So again, first step, we do the cubed root of x cubed, and then the cubed root of 8. So a is equal to x, and b is equal to 2. Your equation has a squared and b squared, so we're going to square those. That's 2 squared, which is 4. And then all we're going to do is now substitute. We start with a, which is x. We're going to subtract our b, which is 2. Then we have open parentheses a squared, which is x squared, plus a times b. So we're going to be multiplying a times b, which is 2x. And then we're adding b squared, which is 4. We're going to do the same thing for this next one. We're going to do the cubed root of 27x cubed, and then the cubed root of 8. When we do the cubed root of 27x cubed, it's basically doing the cubed root of 27, which is 3, and the cubed root of x cubed is x. Then my b is going to be the cubed root of 8, which is 2. We're going to square the a and square the b. So my a squared is 3 squared x squared, and that gives us 9x squared. And this is 2 times 2, which is 4, or 2 squared is 4. So again, we're going to be using the same formula. So we start with our a, which is 3x. Then we add our b, which is 2. And then we get our a squared, which is 9x squared. And then we're going to subtract a times b, and that's going to be 6x. And then plus 4, which is our b squared. Oops, I forgot to put the square. The next one, again, it's going to be a difference of squares because there's a minus. So we started the same. Cubed root of 8, cubed root of x, and then cubed root of 64. We get 2x, that's going to be our a. Our b is 4, because the cubed root of 64 is 4. Then we're going to square the a. So a squared is 2 squared times x squared, and that gives us 4x squared. Our b squared is going to be 4 squared, which is 16. So we get our a, according to the formula, 2x, subtract our b, which is 4. Then we get our a squared, which is 4x squared. We're going to add a times b, that is 8x. and then plus b squared, which is 16. This is my p, this is my q. So the factors of 18 are 1 times 18, 2 times 9, 3 times 6, 4, 5, 6, and then it starts repeating. So those are all my factors. The factors of 2 are 1 and 2. So we need a 2 by 1, 2, 3, 6, 9, 18. And then we have our factors of 2. So we do P over Q. So these are all my P's and these are all my Q's. So it's P over Q, P over Q, over here too, but now we're going to use 2 as my Q. Is simplify. So we look through each one. 1 divided by 1 is 1. So we have plus and minus 1. 2 divided by 1 is plus and minus 2, plus and minus 3, plus and minus 6, plus and minus 9, plus and minus 18. 1 over 2, plus and minus 1 divided by 2. 2 divided by 2 is 1, and we already have 1, so we don't have to write it over. Then we have plus and minus 3 over 2. This is equal to 3. We already have 3. 9 over 2. And then 18 over 2 is 9, so we don't need that one because we already have 9. So these are all the possible solutions for the possible roots or solutions for that function. Let's look at the next one. This is my p, this is my q. So for p, we only have 1 and 5. And then for q is only 1. So we really just needed two columns and 1 row. So here we have 1 over 1 and then 5 over 1. So my possible solutions are plus and minus 1 and plus and minus 5.